Okay, this is Notes 2.2, Part 2 on the relationship of gases, and we went over all of these laws last time with demonstrations. Most of my classes got this, but if you didn't, I'm going to go ahead and do this now. Please bear with me. The combined gas law, if we combine all three of these gas laws together, it looks like this. Okay, and further we can cross multiply like such, and we end up with P1 V1 T2. Oops, sorry, that's a T2. That's T2. Fix that, please. P1 V1 T2 equals P2 V2 and T1. Okay, this makes doing the problems that I'm about to show you a little bit easier if you rewrite it in this form right here. Okay, because it takes everything out of the denominator. Let's go ahead and solve. A sample of gas at 1.4 atm increases in volume from 250 mils to 400 mils at a constant temperature of 30 degrees Celsius. Now if something says it's at constant temperature, if it's at a constant, well, first of all, let's say this. One, here are the rules. You must always convert to Kelvin in these gas law problems. And then two, held constant means to ignore. Okay, in other words, it's not changing, so you can ignore it. Remember, the gas laws have a before and after, a set of circumstances before and a set of circumstances after. So it's a changing situation. If something's being held constant, one of the variables is being held constant, that means it's not changing, so you can ignore it. So let's plug everything in. A sample at 1.4 atm pressure increases in volume from 250 mils to 400 mils. So initially it's at 250, it increases from 250 to 400. So initial is 250, final is 400 at a constant temperature of 30 degrees Celsius. Okay, the temperature does not change. What is the final pressure of the sample? Also, we can ignore N. Remember, N means number of particles, and the unit for N is moles. Okay, so we can ignore that for right now. So let's go ahead and write out our equation. Our equation looks like the following. P1 V1 T2 equals P2 V2 T1. Again, we can ignore temperature. And there's our final equation. All we have to do at this point is plug in our values. So for P1, we write 1.4 atm times volume 1, which is 250 mils, equals P2, which we don't know as of right now. So we just write P2 times V2, which is 400 mils. Notice now we are solving for P2. Okay, we're solving for P2. So to solve for P2, we have to isolate P2. And we do that by dividing both sides by 400 mils. Okay, and we can cancel this one out, And notice the units over here, mils, cancels. That leaves us an ATM, which is a unit of pressure, which is what we're trying to solve for. When we do this math, you can do this in your calculator and you should get 0.875 ATM. Next, a sample of neon gas in a rigid 1 liter container at 15 degrees C has a pressure of 600 torr. What is the final pressure if the sample is heated to a temperature of 100 degrees C? Now, in this case, a rigid 1 liter container implies that the volume does not change. Rigid means it's very sturdy and it does not have any sort of give. Okay, it's a rigid container. You can imagine something like a coffee can would be a rigid container, whereas a balloon would be a non-rigid container or a flexible container or an elastic container. Okay, so let's go and plug everything in. 15 degrees C is our temperature. What is the final pressure if the temperature is heated to 100 degrees C? Okay, so 15 degrees C, 15 plus 273 equals 288 Kelvin. So that is our initial temperature. (100 degrees plus 273 is simply 373 K, and that's our final temperature. Volume we don't have to worry about. Pressure initial 600 torr, and our final we don't know. We're solving for final pressure again. Okay, so let's go ahead and do our equation. P1 V1 T2 equals P2 V2 T1. We can scratch off volume. We don't have to worry about it. Okay, we don't have to worry about volume, so let's go ahead and plug everything in now. I'll do it on this side. Pressure 1, 600 torr. Times temperature 2. Be real careful now. 373 is temperature 2. Equals pressure 2 times temperature 1, 288 K. Be real careful. It's easy to mix these up. The math is not difficult. It's just multiplication and division, but you got to be real careful when you're setting these up. To solve for P2, I divide both sides by 288K. Notice the K's cancel. Well, that whole thing cancels, and then the K's cancel. And when I do my math, I get P2 equals, my units are torr, 777 torr. Okay. Let's go ahead and do the last one. And then I'll teach you how to do counting gas particles later. I've got to look at it myself, okay? I don't know if we're ready for that yet. A sample of carbon dioxide at negative 10 degrees C occupies 600 mils and has a pressure of 450 mmHg. Okay, let's highlight everything. What is the volume? We're looking for volume if this of the sample if the sample is brought to STP. Now, looking at this problem, you might go, well, wait a second, we don't have enough information. But remember, STP has a value to it. STP equals 0 degrees Celsius and 1 ATM of pressure. Okay, so they're asking for the final volume. Okay, what is the volume if it is brought to STP? Well, let's start to plug everything in and see. A sample of carbon dioxide at negative 10 degrees Celsius So negative 10 plus 273 is 263 Kelvin. Occupies 600 mils. That's our volume. Okay. What is the volume if the sample is brought to STP? Okay, our initial has initial pressure of 450 mmHg. Okay, at STP, we're going to bring it to 0 degrees Celsius or 273 Kelvin. And we're going to bring it to 1 atm pressure or 760 mmHg. 760 mmHg. Okay, let's go ahead and solve this. We write out our equation. P1 V1 T2 equals P2 V2 T1. We don't worry about N for right now. We're solving for V2. To solve for V2, we need to divide both sides by P2 and T1. P2 and T1. Okay, and that will allow us to isolate V2 by itself, and that is our equation. So let me plug everything in. I'll try to put it all in here. P1 V1 T2. Here we go. 450. I'm going to leave the units out on this one, guys, just so that I have enough room. Alright, but you put your units in. P1 V1 T2. Don't mix that up now. That's 273. Oops. 273 divided by P2 times T1. So P2 760. Oops. 760 times T1, which is 263. Okay, when I do that math, you got to show your units. Now I'm trying to save space, but you have to show your units because it's going to tell you that everything cancels out here except for milliliters. Alright, and when I do that math, I get 369 mLs. And that's how I solve this. Okay, I will teach you moles and how to count gas particles at a later time.